Yeah, so, hello, everybody. I am going to be doing a Q&A. So, I'm just getting up the questions, and I'll just be going through all of them, and yeah, so hopefully I'll be answering some of your questions that you had for me, and yeah, hopefully enjoy this video. It's a different type of video, of course, but you know, people wanted it, and I got quite a lot of questions here, so this should be quite a decently long video where I can answer everyone's questions. Firstly, one of my friends, because for some reason he couldn't comment on the community post itself, so he texted me a question, which was, what is my favourite number? My favourite number is 26. The reason, I really have no reason for that. That's just how it's always been, so yeah, that's just what it is. I don't really have a reason for that. I might have had it like when I first said, oh, 26 is my favourite number, but no, I don't remember why. It's just always been my favourite number. Alright, I'm just gonna go through these questions kind of in terms of depth, so how long it will take me to answer them. I'll do Otium's comment, or Stavros, as he appears on YouTube now, last, because he's got so many questions. And alright, let's do this. So, Integral Boy asked, when and why did you start learning maths? When I started learning maths, probably when I was, by learning maths, I guess you mean like more advanced than school maths, and I started doing that around the age of 12, or maybe 11. No, hold on, it'll be 11 or 12, but I think 12. And why was, well, it was because I was just in a maths class, and there was we were doing these questions, and one of them, the teacher was like, don't do this one, you'll learn this later. And so naturally I was curious to see what the question was about, and you know, after some using some basic facts about the areas of shapes and stuff, I realised that it was a quadratic equation, and obviously I had no idea how to solve it. I had no idea they even had more than one solution, because I'd never seen an equation with more than one solution. So obviously I went, because I had no idea how to do it, I went home, and my dad taught me how to do it. You know, I don't know, the quadratic formula is not really something that's, you know, that inspiring for most people, but I know I found that pretty cool. And at some point I just wanted to learn calculus, and you know, after I wanted to learn calculus, I don't remember exactly at what point that was, but after that, you know, I never really stopped learning maths, and eventually I found some advanced maths topics through Informatica and a few different textbooks and whatever, and you know, yeah, that's just how it is. Krish Diman asked, what do you like more, milk or orange juice? Orange juice. He also asked, what is your opinion about linear algebra? Yeah, I guess, what's my opinion? I guess that means, do you like it? I mean, I don't really use it that much. I haven't done it in a while. I like it. I mean, when it starts being applied in cool abstract algebra stuff, that's when it gets really good. So, you know, some representation theory stuff and whatever. You know, that type of thing. That's when I think linear algebra starts to get quite cool. So overall, you know, I don't have a problem with linear algebra. On a similar note, Kasrastini Maths asked about my opinions on analytic number theory. Okay, analytic number theory. Uh, in all seriousness, it's not that bad. I mean, I used to love it. I used to do tons of analytic number theory, you know, especially the zeta function. Polygamma function was something that I loved. So I know a bit of like the elementary stuff. I don't claim to know anything advanced on analytic number theory, of course, but I just kind of stopped being that interested in it, really. But I don't. Again, like in all seriousness, analytic number theory is fine. Obviously, Riemann hypothesis is part of it, so of course it's famous. I do prefer. I mean, if I had to pick, I'd probably pick algebraic number theory out of the two. I think it. I don't know. I really don't know much of either, so I couldn't make a proper decision. But from the little parts that I've seen, algebraic number theory, it's more close to my interests. Especially if you're an algebraic geometer, you'll probably opt for that option too. Because there's so many connections there. But again, they're all connected. Number theory, analytic and algebraic. They're used in. You can use them in each other. And again, there's arithmetic comes into play. And algebraic geometry, that type of thing. So it's quite an exciting field of maths to be researching, I would guess. But again, like you'd have to ask an actual number theorist, whether that's the case. So, it's not bad at all. Again, another question which is not very deep. K-Star Gamer asked, why did you choose the penguin picture as your YouTube channel pic, and what is the story behind the fursuit pic as your Discord profile picture? The penguins one is because I was on my computer. I just started my channel, and I thought, okay, I need a profile picture. So I literally just got the default image, the first thing that popped up, which was the penguins, and I thought, okay, this looks good enough for me, so I'll just keep it. And the fursuit is literally the same. I think before that, my profile picture on Discord was just a picture of a bunch of donuts. Then I discovered that MathBot had this equals fursuit command. Now that equals fursuit command, I don't know why, but I found that hilarious. So I made my profile picture, because this was at the time where I was changing my profile picture constantly, and I guess it never left. Love Maths asked, did you always know you liked maths, i.e. in primary school, and do you have any other hobbies? Okay, firstly, it depends on what... Okay, so in primary school, I never did any maths kind of outside of school unless it was homework, but it was always my favourite subject. I mean, if you asked me in year 5 or something, what's your favourite subject? I'd say maths. I was always quite, I was above average at it, but I was never amazing or anything. And I never enjoyed it that much, I just preferred gaming, I guess, at that time, or doing whatever I was doing at that time. It wasn't maths, but it was always my favourite subject, but I was never that interested in primary school. It was in secondary school is when I became interested. And do you have any other hobbies? Well, obviously chess live streams, whatever. I do enjoy. Other than that, I still play Rocket League. I'm no good, but I still play it. Every now and then because it's fun, and I do also enjoy just watching the buses go by. I do enjoy, learning about the different types of buses, occasionally taking pictures of buses. I don't know why it's buses, but ever since I was like 3 or 4, I've always liked buses, and I always knew the different routes and stuff near me, or even not that close to me either. So that's another one. But yeah, okay. Now let's go on to some slightly more deep questions. Okay, let's see. So, Karan Singh asked, I basically love to know how you study and get good at maths and progress, how you choose material, practice, retain the stuff you learn, and even apply it. Okay, so basically that's asking, how do I progress in maths? How do I study it? Alright, so first things first, new topic that I know nothing about. It looks cool, but, I've never actually done it before, let's say. The first thing I do is, I guess it depends. I mean, nowadays I would not go to YouTube just because there's so few resources for, advanced level maths on YouTube that I completely ignore it now. And just go straight to lecture notes and books and whatever. So I literally just I might look at Math Stack Exchange or Math Overflow. They normally have a question about XYZ resources. I might go through I might skim through a couple of those resources, whatever, to get a slight taste for the subject. Then I'll actually read properly, actually read about it. And the way to retain it, I guess, is to do it, reading it is all well and good, but you also have to be kind of somewhat active when you're learning it. Ask questions about it. If something doesn't make sense to you, then, in the text or whatever, then either try to make sense of it by yourself, or ask someone who would know, even if it's online, and doing at least some of the exercises. I was never actually that big on doing exercises from books, with the one exception being spectral sequences. Those things are, for those it's really key to do exercises. Otherwise, I don't think you can properly get what's happening for spectral sequences if you don't actually bash a couple of computations yourself, because that's a really large part of the spectral sequences, actually doing a bunch of computations or whatever. But in general, I didn't do that many exercises, but whenever I did, I always felt satisfied after I did that, and it did help. So I probably should have done more exercises, but reading, doing, asking questions, that type of thing, that's basically how I learned it. And to even apply it, well, I'll apply it if I see a situation where it naturally comes up, I guess. What do you mean by apply? I guess, if you mean to a problem I see elsewhere, I don't know, I guess, I would work on the problem, and then maybe in the back of my mind I might think, oh, this is exactly like, theorem XYZ in something I learned back there, and then, apply it there, but, I don't know, I guess that's just how you apply things to things, so I don't know how to answer that last part, but, yeah, that's how I learn. Karan Singh also asked, how do you learn, how do you approach topics, what motivations, also why math? I'd also like to know what you want to do going ahead, also favourite food and favourite album. Okay, let's see. How do you learn, how do you approach topics? I guess I already answered that. What motivations? Pretty much my only motivation, okay, well, it depends. I might see a field of maths that I don't know anything about or know very little about, and kind of like skim through a PDF of which I understood 5% at best, and think, whoa, that looked really cool. I want to learn that, and then I might use that PDF or that topic as motivation to learn the prerequisites, because then I'll be thinking, okay, I'm motivated to learn these prerequisites because they will help me understand this cool field of maths which I want to learn. So that'd be my motivation. You know, the core of it though is me just looking at a piece of maths and saying, whoa, you know, that looks cool, I really want to understand that. So, yeah, that's the main motivation. What I want to do going ahead, you know, I guess go to some good university, become a professor, you know, become a mathematician, whatever, and do research and you know, discuss my work and with my colleagues and whatever, and you know, do all of that cool stuff. Basically just that. Favorite food and favorite album, both very difficult questions. Now, music-wise, my favorite genre by far is grime, which is probably unexpected for most of you. But yeah, my favorite genre is grime, and my favorite album is probably. It's probably got to be Famous Question Mark by Jamie. Even though, you know, it wasn't it or Counselor State of Mind by Skinny Man. You know, both I mean, the famous one by Jamie, it wasn't actually famous, it was just called Famous Question Mark. You know, it didn't sell it wasn't that successful, to be honest, but, you know, when it first released or whatever. But or at least compared to his albums now. But, you know, upon listening to it the first time, I instantly, you know, loved it. So I've got it on repeat again and again now. And Council State of Mind is, you know, it's recognised as one of the best UK hip-hop albums of all time as well. And, you know, I have to agree. I don't know anything about UK hip-hop, but, you know, that was a great album to listen to, so yeah. Favourite food, that's also a very difficult question because I love food. My favourite food would be, I have no idea, literally. As long as it's not seafood or healthy in any way. In fact, if it's not healthy in any way, I'll probably love it, so yeah, it's not a great answer to your question, but you know, that's basically my attitude towards food. Alright, so those two questions. Here's an interesting one. Aravind Suresh asked, what do you think will encourage more youngsters to take up maths? Do you believe that the system that currently exists discourages talented mathematicians and leads them into other fields? I certainly think that the system, you know, I certainly think that the system could be improved. You know, I hear all the time in real life and on Discord, you know, people saying, oh, hate maths, you know, it's so boring, whatever. And, you know, I've got to agree, you know, not about their statement, but about the maths that they're actually doing for that piece of homework or whatever. You know, say you're learning about, I don't know, the quadratic formula or whatever. Now, obviously the teachers have to teach you so that you get a good grade, and I understand that, but I don't know. I feel like if I see a picture of someone's homework and it's just 50 different quadratic equations, you know, and you have to solve them all, that's, you know, unless that guy already loves maths, that's not particularly inspiring at all. You know, him just having to factorize or just plug in negative b plus or minus square root, blah blah blah, every single time, you know, on end. First of all, it's pretty misleading as to what, you know, maths will look like in the future if we were to pursue it. So that, first of all, that's an issue. Secondly, you know, even if that was what maths looks like, you know, it's not particularly fun to do or inspiring. So I guess what would be more fun is, I don't know, I guess, you know, I'm trying to think back to what would get. I mean, I guess there's quite a lot of cool stuff you can do with say some elementary number theory, which, you know, is quite cool. I think it's definitely more fun than a lot of the school maths itself. You know, some competition style questions are quite, you know, they're also quite cool. Some proof style questions, you know, proving some theorem, you know, might, you know, that's quite mind blowing or quite unexpected or whatever, that might also help. But yeah, I definitely think that if you want to inspire more talented mathematicians to pursue pure maths, then the school system has got to change it up at least a bit. You know, at least like add back some group theory or whatever to the A-level curriculum or whatever. Because that's more of a taste of what pure maths will be like in the future, I think. So yeah, that's a good question, actually. Alright, let's see what other questions there are. Let's see. Okay, Benjamin Adrenaline asked, what is your opinion on the origin of maths? Okay, who had the most input into common ideas today? Was it the Babylonians, the Romans, the Greeks, the British? Lastly, what is your favourite broad field of maths? Okay. Now, what is your opinion on the origin of maths? I guess, I don't know who, like, you know, who were the first people to realise, you know, that this was 2 and this was 3 and whatever, and 2 plus 3 equals 5. I don't know who were the first people to do that, but I guess the first people to properly study maths have got to be the Greeks, right? I mean, you know, even today in schools, you know, you're taught Pythagoras' theorem, you know, all of the geometry you're taught was probably somehow invented by the Greeks or whatever. You know, obviously they weren't the only ones, you know, I think there were quite a lot of Indians as well, in like, you know, the 11th century or whatever, who also did quite a lot of work on algebra. You know, I think there was some Indian mathematician a long time ago who came up with the quadratic formula first. You know, all sorts of different people, you know, got the ball rolling, so to speak, maths-wise. Now, I'm gonna kind of, sort of sidestep the next question. I mean, not sidestep it, but slightly change it, by just answering who had the most input into common ideas today. Actually, no, I'll answer that, as it is already. Was it the Babylonians, the Romans, the Greeks, the British? Probably the Greeks. I actually don't know much about, you know, early maths, but, you know, I think that still the Greeks, you know, all of their proofs and stuff, a lot, you know, geometry, you probably still could, you could probably still list Euclidean geometry as a prerequisite for a lot of, you know, modern maths and whatever, like topology, geometry, that type of thing. So I'd say it's probably the Greeks. But in terms of a person, or, you know, that type of thing, who had the most input into common ideas today, that would have to be Grothendieck, right? You know, common ideas today, I take that as pure maths research right now. And if you had to pick out one individual whose name pops up the most or whatever, it would probably be Grothendieck, right? He did a ton of stuff in a ton of different fields of maths. You know, he completely reformulated algebraic geometry. You know, he worked on a lot of different fields of maths which are still obviously really relevant today. You know, algebraic K theory as well. That type of thing. So I guess that he's the one who influenced modern ideas today. If by that you mean pure maths research. Okay, let's go on to another question. Oh, I forgot to answer this one. How do you feel about your Discord server? Also, what are your opinions on foundations? Server's great. You know, if you haven't joined it, you definitely should. Opinions on foundations. I've never done foundations. You know, I've never used foundations. I've never had the need to use them. So, you know, I really have no opinions on foundations, unfortunately. Let's see. I'm just going to try and answer the questions which are not, like, you know, long comments with a bunch of different questions. So I guess that leaves me with Dennis Gokshu's question. Which is actually an interesting one too. How do you imagine certain mathematical structures, objects, concepts, like categories, manifolds, groups, fields, functions, and types of morphisms and whatnot? Are they rigid objects that you can hold in your hands, objects that you can inspect almost physically, and with which you can play around? Are they just abstract symbols you get to manipulate with no apparent physical illusions, with rules that happen to reflect reality sometimes? Or is it some other which I can't currently realise at this moment? Okay, so I guess immediately what I'm thinking about is I've scribbled a problem down on the board and I have no idea where to start. You know, what am I thinking? I never really think of them as physical objects. I don't know if that's a common thing that mathematicians do. If you know they kind of can see like the field as, I don't know, like a ball or something, and they can, you know, squish it or whatever. But really, to me, I'm just staring at a bunch of symbols which I can you know, maybe apply. I can apply F to this group, and hopefully F is surjective, and what does that do, and you know, whatever. So I guess it would more be the second option, the abstract symbols that I get to manipulate, which appear to reflect reality sometimes. I guess would definitely be that option, you know. I definitely wouldn't, you know, I'd probably just be scribbling a bunch of, you know, in hindsight, stupid notes on the board, and then rubbing them out again, and hopefully I'll get the right solution in the end. But no, I don't. Obviously I have learned physical intuition for a few different, like, you know, things like homotopy groups of spheres. I know, like, you can wrap spheres around each other and whatever, but even when I'm doing that, like, you know, I'm never really imagining spheres actually wrapping around each other. So yeah, definitely the second option. Okay, let me just go through all of the comments just to... Oh god, yeah, there's one more. Here we go. Love Maths said, here are a few questions, Greg. And I'm going to answer them one by one because it will take me a while to read the whole comment. So, 1, what is your favourite area of maths and how did you start studying it? I forgot to answer what is your favourite broad field of maths in Benji's question, but I guess here it is again, so, you know, no matter. What your favourite area of maths and how did you start studying it? My favourite area of maths is got to be it's got to be homotopy theory, probably. Yeah, homotopy theory. And how did I start studying it? Well, I began by studying topology, which naturally led me to algebraic topology, which naturally led me to homotopy theory. And each step of the way, I really thought, you know, this is really cool. But eventually, I kind of landed at homotopy theory, and you know, that's a really deep subject, which is pretty active today. you know, I'm currently learning that and, you know, related things to homotopy. 2. What was your first topology book, and do you have a favourite topology book? What was my first topology book? 1 second. It was this one here. It was Bert Mendelssohn's Introduction to Topology, and it's quite a short text. You know, it doesn't go into, you know, great amounts of detail as, say, Munchre's might into point set topology, but, you know, I got this in Christmas 2019, right? Asked for it for Christmas, and I think it was my mum who got it, I believe. And, you know, I definitely learned quite a bit of at least set theory, if not also some topology from this book too. And, you know, I think it actually is a very underrated introduction. I don't really see it being mentioned much when people talk about, you know, what's the best introduction to topology, because everyone goes straight for Munchre's. So yeah, this is actually quite a decent text on topology. You know, you might want to supplement it with Munchre's just to fill in the gaps, but I think that, let's see, what does it actually cover? You know, it covers, you know, compactness, connectedness, topological spaces, you know, it actually puts quite a lot of emphasis on metric spaces too. And yeah, I think it even goes into homotopy in the fundamental group at the end, or at some point at least. So, you know, it also gives you a flavour for what algebraic topology might look like. So, you know, I do think that this is a good text, especially if you want to learn topology somewhat quickly and you don't want to go through all, like, you know, whatever, 8 or 9 long chapters of Munchre's before you get to algebraic topology. So yeah, this is quite a good topology book, but do you have a favourite topology book? I guess it depends on what you mean. If we're including homotopy theory into this bracket, oh, that's toughy. See, do I have a favourite topology book? I guess, I don't know. I mean, it might just be... Oh, yes, I actually do know. Yeah, my bad, yeah. Here it is. I realised that it's backwards on the screen, but it's called Stable Homotopy Theory and Generalized Homology by Adams. And this book here is a real classic in stable homotopy theory. Even though it was published in, you know, it's literally typewriter stuff. Here, if we just go onto like a random page, let's say this one, you can see this typewriter. So this was pre-latex, but even so, even though it's quite an old book, you know, lots of homotopy theory texts still reference it, and homotopy theory papers, you know, still reference it because, you know, it is a real classic, and it does go into quite a lot of, you know, the modern homotopy theoretic ideas. So this is a really good book. I really like it so far, at least. That was a good question. Do you know when and where is the Eurovision contest this year? Has Ireland ever won Eurovision contest? Ireland has. Ireland's won it a bunch of times. I'm not sure exactly how many, but they've won it a bunch of times. And where and when? I know when is 22nd. Where is a mystery to me. 4, your favourite sport, tennis. 5, your favourite maths equation. Oh. Now, okay. Oh god. Your favourite maths equation. So I guess I'm just gonna take that as... I guess, okay, if we're strictly talking about equations, you know, there might be a theorem which I like which isn't technically an equation. So I guess the first thing that pops to mind is this is probably going to be backwards for you, but Stokes' theorem. Here's the generalized Stokes theorem. You probably can't read that, or it's backwards or whatever. But the generalized Stokes theorem is what I've written down on the board, and it is really neat. You know, the way that it works out so nicely like that is really cool, and you know it's quite good motivation for the de Rham cohomology, for example, as well. So, yeah, there's that added bonus too, but you know, that is a really cool theorem, so whatever. 6. How do you do your research? I doubt you covered topology in high school, so is anyone giving you guidance? By research, I guess you mean like, how do I learn stuff? Because I'm not actually doing any proper maths research yet. I do not cover topology in high school. Is anyone Not really, no. I just kind of, you know, wander around in these different fields of maths, and hopefully I pick something up and, you know, learn a bunch of stuff, of which I think looks cool. No one's really giving me guidance, although I guess it would probably be beneficial if someone was, but whatever. That's okay. You know, I kind of like just wandering around, you know, different fields of maths, you know, the freedom to just say, nah, this isn't very cool, I'm just going to learn this instead, or, wow, you know, I really want to learn this, I'm going to stop everything to just learn this specific field of maths, but probably not the best way to learn maths, but, you know, it's fun, and, you know, I don't really need to be working at, you know, the optimal efficiency right now, just, you know, enjoying myself, and whatever. 7. What's your favourite YouTube video? I love Smash Product because you made that great song. Smash Product, Smash... Well, actually, if you watched my latest video on the entire Here's a Brook spectral sequence, so part 2 of my spectral sequence talk, I do sing Twinkle Twinkle Little Star, but instead of twinkle I say Z2, and instead of little I say 0, and instead of star I say the Z. So, you know, Z2, Z2, 0, Z, 0, 0, 0, Z. And that is supposed to, and that is actually the you know, the 8 homotopy groups of the real K-theory spectrum. So, you know, it is a useful song to know. And yeah, you know, there's another song for you, I guess. What do you plan next video about? Next video, hopefully it will be someone else on my server giving a talk, or, unless you count this video, but I guess you don't, I might do a talk, maybe another, I might just do a homological algebra video, just so I'm not, like, you know, not doing anything on my channel, whatever, but really I don't really have a plan for the next video. We'll just see how it goes, and hopefully I'll upload one fairly soon. 9, do you enjoy science, i.e. physics, chemistry? Science is okay. I never really liked it as much as maths, but I don't dislike it, so. 10. What do you think schools can do to encourage young mathematicians? I've also answered that one, but there's another one. It says, and finally, who is your favourite mathematician? Jacob Lurie. Yeah, Jacob Lurie. Yeah, or Peter Scholze. I guess I can give those two. Those are both great mathematicians, and especially Lurie, he works on stuff which I'm interested in, and Scholz, I've heard, is just a really nice guy, and also, obviously, a really great mathematician too, so, yeah. Okay, now that we've done let me just scroll through the questions real quick. yeah, I've done all of these questions except for this really long comment from Otium, which contains a lot of questions. Let's see. Let's just go through them. What are your thoughts on the Yoneda perspective? Now, I'm guessing by this you mean the thing where it's like, tell me all of your friends and I'll tell you who you are. Or, in particle physics, when they say, when they have all the different particles bouncing around and, if you know everything there is to know about the particles next to that particle, then you can tell where the particle is or whatever, something like that. Or you can tell the properties of that particle, whatever. That type of thing, so if you're given a mathematical object, then you can determine it just from looking at all of its properties. I like that perspective, it's obviously well founded in category theory by the Yoneda lemma, so I don't know why I wouldn't like it, but, those are my thoughts on that. Is mathematics invented or discovered? Discovered. What do you like so much about homotopy groups of spheres? Or, what is your current favourite thing from maths and why? Firstly, I don't know what I love about homotopy groups of spheres. I guess it's like asking a number theorist, why do you love primes so much? Firstly, determining the homotopy groups of spheres is an absolute classic problem in homotopy theory. It's a really natural question to ask as well. You might hope that it's a simple answer, like it is for homology. But in reality, it's actually a really deep question which has been studied for ages. And I just love it. I mean, I love how random they seem to be and how difficult it is to compute them. The fact that they stabilize at some point is also pretty cool to me. The fact that there's so many unknown questions, there's a lot of room there for improvement. So yeah, that's all very, very cool stuff. So I guess that's why. What is your favorite? I'll answer this because homotopy groups of spheres is just something that I've always loved. But right now, I guess I would say higher algebra is my favorite thing for maths because that's what I'm learning right now. And I'm really enjoying it right now. And also spectral sequences are really cool. I'm not learning. I'm learning about them kind of more passively now because I moved on slightly to higher algebra, one could say, but I still think they're really cool, and they do also come up a lot, even though derived categories make for a better setting to compose derived functors, for example. For actual computations and stuff, you still want to use spectral sequences. So they're also really cool. What are your thoughts on applications or physics, and are you planning on learning physics? Thoughts and applications are, I don't really care about whether, say, I do a piece of research in homotopy theory, and it gets applied somehow in physics. I'm not the type of mathematician, or I hope right now, if I were to do that, I would not be the type of mathematician to get angry. Say that, I'm not going to be angry that my maths has been applied in physics, it's impure. But then again, I'm not actually striving to look for applications myself. Are you planning on learning physics? Not really, but I'm not planning to, but I might, I can't say for sure that I won't become a physicist, for example, or even learn physics to a decent degree, but I'm not actually planning to. What, in your opinion, is the hardest concept in maths that you have encountered? Oh god. Yeah, all of maths is, really difficult. That's why there's so many open problems. Hardest concept you've ever encountered? Oh, okay, let's see. Maybe, I don't know, you know, the hardest concept I've ever encountered has got to be something that I've encountered recently. Might be... let's think. Something... Maybe... Oh... Okay, you know what, I'll come back to that question. What is the connection between topology and algebra, algebra and geometry, number theory and algebra, and in general, how do different fields of mathematics intersect? Well, obviously, okay, what is the connection between topology and algebra? Well, that would just be algebraic topology, right? You know, I think it's very reasonable to say that that is an application of algebra in topology. But you know, one could always argue that that's not exactly true, because using algebraic topology, one can easily show the fundamental theorem of algebra. So, you know, we are getting some return there too. So, I think that's the main link, you know, algebraic topology. Algebra and geometry, again, algebraic geometry. You know, that's that. And number theory and algebra. Algebraic number theory, you know? Algebra is really useful, you know, everywhere, because it's such a convenient language, you know. That's why category theory is used a lot, you know. It's really convenient to work in a group or a category or something like that, you know. And in general, how do different fields of mathematics intersect? Well, I guess, you know, it takes a really clever guy to be working on a problem in a certain field of maths and to think, hang on a minute, you know, using the methods of this field of maths, we can actually solve this problem here. And so then he brings in the tools from this field of maths and he applies them over here, and suddenly, you know, they've solved that problem quite simply, and suddenly everyone starts thinking, oh wait, this field of maths can also be used here to solve this problem too, much more easily, or whatever. And so I think that's how it happens. And also, you know, this field of maths might be thinking, okay, people are using my tools over here, so maybe I can use their tools over here. And, you know, so maybe they think, oh, here's a purely, say, algebraic problem, and then here's like number theory, and they're like, oh, the way that he proved that purely number theoretic question can be used over here. And then this guy comes over here, and suddenly they start, like, you know, intersecting more and more, and, you know, then that intersection becomes a full field of maths, say, algebraic topology or whatever. Of course, you know, the more experienced mathematicians or physicists or whatever, or more clever people in the comments can correct me, or like give more examples of how different fields of math can intersect. But you know, that's how I think of it. What do you think is the most significant unsolved mathematical problem? It depends on what field of maths you're working in. For number theory or analysis, I'd say the Riemann hypothesis. You know, I think it was, you know, there's tons of conjectures which are proved just as a corollary of that, and the majority of them, I believe, you know, Riemann hypothesis experts can correct me, but the majority of the applications of the Riemann hypothesis will probably lie in, you know, analytic number theory or complex analysis and that type of field of maths. So if you're thinking from that perspective, then the Riemann hypothesis. In, say, homotopy theory, or, you know, algebraic topology, maybe one of the most important questions would be, say, I don't know, how to compute these homotopy groups of spheres. Maybe you could argue that for some people that's the most important question, because that would then imply something about the spectral sequence. You know, if it were true that, you know, this homotopy group is equal to that one, then this spectral sequence must act like this, and then that will help me out in that computation. So I really, and there's plenty of examples of this. You know, in algebra there might be a representation theory problem which is really helpful for him if it's solved, and then for that one guy, that's the most important problem in mathematics. So, you know, I think it depends on who you're talking to. For a physicist, so for example, you know, a different field of problem in mathematics might be really important, you know, and if solved, you know, could have applications in physics which are really important. How is it? Oh, okay. Should pure mathematics be important to the average person? Is it? No. I don't think the average person cares about pure mathematics that much. Should it be? Nah. Why should it be important to the average person? If the average person is working in, say, I don't know, as a builder or as a tennis coach or whatever, why should pure mathematics be more important to them than what's already important to them? You know, their family or their job already, you know? No, I don't think it should be. Obviously it would be nice if, you know, you could just add it onto their collection of interests, because then the whole world would be more clever and, you know, be more good at maths and, you know, help out mathematicians working on problems. But I don't think you should prioritize them being interested in pure maths over their current interest. And that's also probably not feasible to make the average person interested in pure maths. I think it's quite an acquired taste. Obviously, for example, if you're relating it back to an earlier question about how we get more young people into pure maths, the methods I suggested might get more people into it, but it's not going to get, you know, you're not going to suddenly see like 50% of high school students become mathematicians or something. I don't think it's that feasible to get everyone interested into pure maths. Obviously, if you could, it would be very nice, but, you know, I'm just being realistic here. In what ways do you gain satisfaction from mathematics? The main way is if there's a problem which has been bugging me for ages, and suddenly I unlock it, and everything becomes clear. You know, everything that I've learned about that topic, you know, just suddenly comes into play, and it all works out so nicely, and the final solution is just a page or 2 pages of just beautiful step by step, you know. Now we use this theorem that I proved earlier, and, you know, here comes the crucial moment, you know, we chuck in a, you know, minus sign or whatever, and it all works out, and that's really satisfying. Just the feeling of satisfaction after solving a problem that you haven't solved in ages is great. Also, you know, reading about a mind-blowing theorem where it's just, you just think, firstly, how the hell do you prove that? And secondly, that is so nice. How did it work out so nicely? You know, something like Stokes' theorem. You know, that takes pages to prove, but it just works out so incredibly nicely like that. So, you know, yeah. So those are the 2 main ways. But obviously, you know, even just talking about maths and, you know, with someone about a subject that I'm not even that well versed in, and then, you know, by talking about that field of maths, I suddenly, like, you know, I get better, or at least I get a feel for the general ideas which I might not have thought about before. So that's also quite satisfying. So, you know, there's plenty of ways which I get satisfaction from mathematics. I think it's also important to note that it can be frustrating too. You know, if in the days that I just couldn't solve that problem, I'm gonna get frustrated. I'm gonna bang my head on the board a couple of times, or call myself stupid or whatever. But I think that it's that frustration in part that makes the end result so satisfying too. So I guess it's worth it. How is it important to find more elegant, simple, and beautiful proofs in mathematics for the same thing as existing ones? It is important. It's not vital. I mean, I guess if you had to prioritize finding new theorems, new proofs over, making the old ones really, really cute, obviously you'd prioritize finding new theorems. But I think if you do find a field of maths or whatever, or for example category theory, okay? Van Kampen's theorem, it can be stated much more lucidly with category theory. And I think that's important to note, even just so that the next people who learn about Van Kampen's theorem can understand it in a much more, elegant way. So then it will be more clear to them, and they can use Van Kampen's theorem in a wider range of situations just because they understand it better. Or, whatever. If you make a proof more elegant or more simple, probably more important to make it more simple then people who learn about it next will learn the more simple proof and will be able to apply it in different situations just because it's more elegant. And so I think that is important. But of course it's not more important than finding new theorems, of course, but yeah, it is important. Can you do math without knowing how to count? Depends. Obviously you wouldn't be able to do calculus without knowing how to count, but you might be able to do some category theory maybe without knowing how to count. It would actually be very hard to do simplicial. It would be very hard to do higher category theory because simplicial sets are defined as these, order sets and whatever, so you'd have to know how to count for those. But to know the basic definition of a category, or, some functors and stuff like that, you might be able to do that without knowing how to count. That's actually quite an amusing question. That's quite a funny question, yeah. There might be some abstract enough pieces of maths so that you can do it without counting, but majority of maths, no, probably not. Even higher category theory. And so all of those subjects which are unlocked by higher category theory couldn't be done. Similarly for calculus, all of that field of maths which is unlocked by calculus can't be done. So there's a tiny little area there which might be able to be done, but you should learn to count, probably. Does mathematics ever stop? No, it doesn't. Maths is infinite, I think. There's always going to be infinitely many problems to work on. Infinitely different unsolved field, undiscovered fields of maths which are never going to be discovered or whatever. Infinitely many different creative solutions to different proofs. So I don't think it will ever stop. Just because maths kind of like studies like a whole different, it's like a whole different universe, and that universe is endless. So maybe in like millions and trillions of years, physics might stop just because we get to know everything there is to know about the universe. But mathematics is kind of like a whole new universe to study, which is, in my opinion, infinite. But I can't prove that. I'm very, very ignorant about physics, so trying not to get too triggered if like there is some paper which basically says physics will never stop either. But I just think like trillions and trillions of years of research might be able to be dedicated to understand every single particle of the universe or whatever. But obviously it's never going to stop before the sun explodes. So obviously got to keep working on that too. I don't think it'll ever stop, basically. What is a theorem/exercise that took you a surprisingly long amount of time to prove/solve? A theorem or exercise that took me, it'd probably be some, maybe proving a circle theorem. Took me, actually no, that's a lie. That's a good question too. Um, um, oh, okay, maybe showing that Klein 4 and the integers mod 4 aren't isomorphic. That took me ages. I don't know why. I don't know why I just didn't think, to look at the orders of the different elements or whatever, but yeah, that took me a while. I guess you could say that's a proof that took me surprisingly long to do. What is and are your favourite theorems? I've already got Stokes' theorem written on the board. My mind's gone blank. There's I like tons of theorems. There's a few that look quite ugly, but there's many elegant ones which I really like, which I just like. There's not one which really stands out to me at the moment. But I've already got Stokes' theorem on the board, so I guess you could say I've already answered that question. Where are you planning to go for university? No idea. Somewhere good, hopefully. Where do you see yourself in 10 to 20 years? In 20 years, I see myself, maybe doing a PhD or, first year as a professor or something. Or no, actually no, in 20 years I'll be 34. No, okay. In 20 years I see myself, staring at a blackboard, working on this unsolved problem, and then I go to lunch, I talk with my mathematical friends and whatever about the problem, and then talk about their problems too and whatever, and I'm having a great time, and I'm just doing mathematics with all my new friends at the university, and then I have to teach the students whatever, and then I go back to the problem, and eventually I solve it, and I write a paper and whatever, that type of thing, and then I see myself having a great time basically. But, obviously that might not be real. Hopefully that's realistic, but, we'll see in 20 years. What do you think of mens sana in corpore sano? Yeah, I think it's true. Again, I don't know how I could dispute that, so yeah. Have you ever naturally encountered an open problem? I'm gonna kind of cheat with this question and say yes, because I study homotopy groups of spheres, which is obviously an open problem. Yeah. What is your favourite group, /field, /ring, /vector space, /manifold, /category? Favourite field. Field with one element, yeah. Favourite, no, I'm not, I don't have a favourite field or manifold or category. I just don't. I think they're all good. Maybe the trivial group or whatever is not as exciting as another group or whatever, but I don't really have a favourite, to be honest. No. What is a short and beautiful equation? Stokes' theorem. I think you wanted me to say that, to be honest. Really, what else was I going to say to that? Do you know any programming, and what are your thoughts on computing and mathematics? I don't know any programming, unless you count knowing LaTeX. Thoughts on computers and mathematics. Of course, first it might be somewhat scary to think that there are computers and mathematics who are learning how to prove things or whatever. And obviously there's this new lean stuff which is being developed by Kevin Buzzard and a bunch of other people, which I think is exciting. I would like to hear about what's going on there, but I can't say I understand it at all. And I'm just going to continue working on pure maths and hope that I don't get taken over by robots. Yeah. What are future video ideas you have? I've already answered that. What is something you currently don't understand but would like to understand? I would like to understand a bunch of stuff in homotopy theory. So there's topological, Hochschild homology, topological cyclic homology. There's a bunch of there's a lot of Goodwilly calculus which I've never done, which I'd like to understand. So a bunch of very top and algebraic geometry. I'd like to do more algebraic geometry and algebraic K theory. So there's a ton of topics which I still would love to do, which I haven't done at least in detail yet. So still, obviously infinitely many different fields of maths for me to study still. What is something you can't... what are your thoughts on the education system? Already answered. And that concludes the Q&A. So, if you've watched the whole hour, then I have a lot of respect for you. And yeah, thank you for watching this video. I'm going to stop recording before the phone runs out of battery. But yeah, thank you for all your questions. You actually gave me a lot of material to work through here. And yeah, hopefully enjoyed my answers, and thank you for asking the questions. So yeah, goodbye.